So let us say now we solve a very normal way, very fundamental way, like I'm not going for any logics and all here. So L2 and L1, L2 and L1 are the lengths of the springs, relaxed lengths of the spring 1 and spring 2. Upper spring is having the relaxed length L1, lower spring is having the relaxed length L2. Okay na? Then what is the height of the M2? Height of the M2 from the ground. For height of the M2 from the ground, it should be what? L2 minus compression. Compression in the second spring. What is the compression in the second spring? I am taking as X2 is the compression in the second spring. So I can write down K2 X2 should be equal to M1 plus M2 into Z. Total weight it has to bear. Lower spring has to bear both the weights M1 and M2. Then what is the X2 value I can write down? M1 plus M2 into G by K. This is the X2 value. Then what is the height of the M2 block? L2 minus X2. Okay na? Clear? L2 minus X2 is the height. Now what is the compression in the first spring? The compression in the first spring I am taking as X1. Maybe little lengthy way. So K1 X1 should be equal to M1G because it is in equilibrium. Then what is the X1 value is equal to M1 into G by K1. This is the X1 value. Now what is the length of the spring now? This length of the spring is L1 minus X1. This length. Then what is the height of the M1 block? Height of the M1 block is L1 plus L2. Okay, minus of X1 plus X2. Height, this is L2 minus X2 height, and this is L1 minus X1, this height. So total height from the ground is L1 plus L2 minus of X1 plus X2. So finally what is the initial potential energy of the system? The initial potential energy of the system is M2 into G, L2 minus X2 plus M1 into G, L1 plus L2 minus X1 plus X2. Okay na? So this is the initial potential energy of the system. A very fundamental way I am solving. Next, relaxed. So when second spring is relaxed, no compression. This is M2. Now this is M1. Okay. Now this is relaxed state. Second spring is relaxed state. That means what is the height value? Height value is L2 only. Length of the spring is L2. Length of the spring is L2. It is relaxed means M2G. M2G is balanced by whom? M2G balanced by this spring. So that means this spring has to extend. This spring has to extend. The length will be more than L1. Which is K1 into some X0 I am writing. So then K1 into X0 should be equal to M2G. When K1 into X0 is equal to M2G, then this spring will be relaxed state. No weight will act on it. So I think no need to say. So what is the X0 value is equal to M2G by K1. Right? So that means what is the length value? Length of the spring is L1 plus X0. It is in extended state. It is in extended state. Okay, X0 value already we got. Then what is the height of the M1 block from the ground? Height of the M1 block from the ground is L1 plus L2 plus X0. So that's why I have taken the L1 L2, because somehow they will cancel out, because they are asking for incremental potential energy. Now tell me what is the final potential energy value? Under relaxed state, what is the final potential energy of the system? System potential energy will be, I can write down M2G into L2, M2G L2 plus M1G into L1 plus L2, okay na, plus X0. Hope you understood. And what is the initial potential energy we got? Initial value I got, I am writing here. Initial value is M2G into L2 minus X2. L2 minus X2 plus M1G into, I remember like L1 plus L2 minus of X1 plus X2. Let us see. M1G into L1 plus L2 minus of X1 plus X2. Okay na? Now what is the difference? Increase in potential energy, final value minus initial value. Okay na? Final value minus initial value. Now cancel out. M2G L2 cancel out. M1G into L1 plus L2 also will cancel out. Final value minus initial value. Final value what will left? M1G X0 left minus of minus of initial value left, m2g x2 minus of m1g into x1 plus x2. See these ones? These are the terms left in the initial potential energy. So then delta U is equal to, now you can simplify, m1g into x0 plus m2g into x2 plus m1g into x1 plus x2. Clear? All of you okay with this? Got it? Now write down all x1, x2 values, whatever we know. So delta U is equal to m1g into x0, m2g by k1, okay na? Plus m2g into x2 value. What is the x2 value means? X2 value is nothing but compression in the lower spring, which is equal to m1 plus m2 into g by k2. This is okay. M1 plus m2 into okay g by k2 okay plus m1 into g x1 plus x2. x1 value, x2 value we got. This is x2 value, no? x2 value, and what is x1 value? x1 value is x1 value where m1g by k1. x1 value is m1g by k1 plus x2 value is m1 plus m2 into g by k2. This is m1 plus m2 into g by k2. So finally you can simplify now all values. What we can take common? K1 and k2 terms are there. This is m2 and m1. See, this is m2 into m1 plus m2 into g by k2. This is m1 into m1 plus m2 into g by k2. So I can write down delta U is equal, this is m1 m2 g square by k1. This is m1 square g square by k1. So m1g if I take common, m1g by k1 if I take common, even g square. m1g square k1 common, then this is m1 plus m2, these two terms. This and this first term multiply. In this is directly m1 plus m2 whole square into g square by k2. Okay, na? Still you can take m1 plus m2 into g common, m1 plus m2 into g by g you can take common, then even g square, then m1 by k1 plus this is m1 plus m2 by k2. Okay, we leave over here. I think you understood the logic, no need to simplify further. According to given option you can identify the answer.